So here we got a nice number theory proposition and we have to prove it. We are given that n is a positive integer and 2 raised to the power n plus 3 raised to the power n is divisible by 7 if and only if n is even, then 7 must have to divide 2 raised to the power n plus 1, and if n is odd, then 7 must have to divide 2 raised to the power n minus 1. So for proving this proposition, we know that 3 is congruent to minus 4 modulo 7, so we can simply use this fact and we can simply say that 2 raised to the power n plus 3 raised to the power n is congruent to 2 raised to the power n plus minus 4 raised to the power n modulo 7, and we can simply rewrite it and we can say that 2 raised to the power n plus 3 raised to the power n is congruent to 2 raised to the power n multiplied by 1 plus minus 2 raised to the power n modulo 7, and this simply implies that 7 must have to divide 1 plus minus of 2 raised to the power n. So, and here can be the two cases. If n is even, then we can simply say 7 divides 1 plus 2 raised to the power n, and if n is odd, then we can simply say 7 divides minus of 2 raised to the power n minus 1. So this simply completes the proof of this proposition. And second statement that we are given is for some positive integer k, there is n is equal 6k plus 3, then 7 divides 2 raised to the power n plus 3 raised to the power n. So we have to prove this statement also. So we can simply say that 2 raised to the power n is equals 2 raised to the power 6k plus 3. So we can simply substitute the value of n and we can rewrite it as 2 raised to the power 3 multiplied by 2 raised to the power 6k, which is equal to 8 multiplied by 64 raised to the power k. And now we can say 8 multiplied by 64 raised to the power k is congruent to 1 modulo 7. And if we substitute the value, so we can simply say 2 raised to the power n minus 1 is congruent to 0 modulo 7. And this simply implies that 7 divides 2 raised to the power n plus 3 raised to the power n by the first proposition that we already have proved.